Okay, Mohammed, do you
Hello,
want to do
people.
this?
Yes. So, folks, we have something amazing plan today. And what you see on the screen is Raspberry Pi 4B to be precise.
Yeah.
And what we are going to do today is boot this board up to a bare metal code which we have written from scratch. And you are just about to see what it does. Piyush,
Okay.
do you want to do the
So,
honors?
yeah, it's a pleasure. So let me just go ahead and do that. So what you see on the screen here is a Raspberry Pi. There is UART connected here, which goes to one of my Linux machines, which we'll come to in a while. There is an SD card here, which has our code. And then there is this power supply, right? So first off, let me show the Linux machine real quick. Okay, so this is one of the Linux machines, and it has the terminal here. What I'll do is start Minicom, which is one of the serial terminals. So what I'm now going to do is plug in the power supply, and then let's go back to the terminal,
Yeah.
and something should
Let's
get
hope.
printed.
Let's hope it
Hope and pray.
works.
Yes,
Ah,
and it
cool.
it it prints. So the prints that you see on the screen here, these are coming from the Raspberry Pi as the first,
Yeah.
um, like the first code that Raspberry Pi executes is enable the UART and throw these prints on the UART. Nothing else is running on it in terms of the processor. So what this demonstrates is that we have this bare metal code which is writing to the UART, and we'll be using the prints on the UART in the future experiments to kind of learn the
Yeah.
concepts of how the A class CPU
Right.
works.
Right. And actually
Right.
debug if we land into an issue or no.
Precisely.
Much more. Yeah.
Right. So let's maybe now unpack all of this and learn about how did we get to this point and how you can also get to this point.
Right.
So let me then go ahead and first kill the
Hmm.
terminal. Uh,
And
how
guys, it's
about
just
we? Mhm.
I just wanted to add, it's really kind of, when you do it for the first time, it literally gives goosebumps. You see a board which has like, multiple cores, GPU, clocks, everything, DRAM in the same package, and you get it out, you boot it, and then to get that actual hardware up and running is something, uh, uh, a really good feeling, I would say.
At least it gives me the feeling of
Yeah,
power, like raw
yeah,
control on the
yeah.
CPU, right?
I'm the king of the hill.
Kind of,
Yeah,
kind of.
yeah. Cool.
Right. Okay. Then let me maybe go ahead and show how we got here. So this is the repository that folks would need to go to. That's number one, and this URL will also add it into the description of the video. So on this repository, you pretty much have all the code required to kind of do the same demo that we just showed.
Yeah,
Now we are going to use code space. So to get the code space, you can click on this button here, then click on this plus icon here to create a code space. In our case, we already have it. So just go to three dots, click open in browser, and it's kind of okay. It was already there. Uh, let me close this. Okay.
hmm.
So it's loading up now.
And yeah,
And
to
yeah,
one point to add. So if you are trying it for the first time, so if you're just creating the code space, then it may take a while because it will set up, everything.
right,
So it will install the tool chain. Everything necessary should just be there. So
right.
you don't have to install anything. Just type some commands and you're good to go.
Right. And then, the entire package is kind of split into four important files. These are the three files, the linker.ld, the main.c, the make file, and the start file. So the main file here, main.c and start.s, are the actual source code. The linker script here, let me clear this. How do I clear this? Yes. The linker script here is just helping with the code placement. And then the make file is going to help us build, so to speak, a
Right.
package, which will kind of, show in a while. And then notice that, with just barely how many, 10 lines?
16 lines there and some 45 lines there. So it's
Yeah,
like, well, 61.
roughly. So
Yeah.
100
Man.
line ish,
Yeah.
let's say 50 to 100, right? So within that, you have the, bare metal on
Hmm.
Raspberry Pi, right?
Like within like 60ish lines, we have been able to show the signs of life.
Yeah,
The board has been able to show signs of
yeah.
life.
And maybe at this point, before we jump into the code, really,
Hmm.
these were the lines that we saw on the terminal,
Yeah.
right? Okay, so let's talk about how things are set up at the moment, and we can go from there. So how about I create a new file here so that we can scribble. Let me just, okay, let me add a new file, some name. So my intention here is that we get a canvas like this, and let me close the main. Yes, okay. So let's draw a diagram to learn this better, and let me reduce the size. Okay,
Hmm.
so we have got the Raspberry Pi, which again will display on the screen in a while, and then there were headers here, right? And then there are three pins here. One of them is kind of the ground pin, which is here, right? Then there was like TX or RX.
Hmm.
Right? These are the UART pins. And then we have like a Linux machine here on which we had started the minicom, right? And what is happening is there is a converter in between, which will also show in a while. So that converter kind of connects to these three lines here, becomes
Hmm.
like a cable, and then transfers as USB here,
Hmm.
right? And that USB is what we connected to. And then there is a processor here on Raspberry Pi. There
Hmm.
was power supply here and an SD card underneath. So as soon as this kind of powers up, we'll talk about the boot flow in a while. But as soon as this powers up, the idea is once the A class CPU takes over, it sends the message and displays it here. Right. So
Right.
this is the arrangement, and we'll kind of show this cable also, the Raspberry Pi also, the pins, so on and so forth. Right. So let's maybe again once again show all of the setup, then go to the boot flow. What all happen? Maybe what we should do is show the setup, show the compilation, then talk about the different files involved. And as we talk about the files, let's talk about the boot flow.
Yeah.
That sounds
Sounds
good.
good. Yeah.
Okay, perfect. So let me go ahead and close. Okay, how do I get rid of this? Yeah, close all of this. Delete, and let me also. How about I go ahead and delete this file? Can I do that? Yes. All right.
Maybe you want to type the show the terminal and
Oh
type the
yes.
command.
Sure. Let's actually go that way. So this is the terminal. Maybe I'll increase the font on this. Can I do that? Yeah.
Hmm.
Okay. Very
Perfect.
nice. Right. So one of the things that I did not speak about upfront,
Hmm.
which we'll kind of get to in a while, is this directory, the SD card. Right. We'll come to that, and that has to do with the files required to boot.
Yeah. And I think it would be good if we come to that after we have gone through the boot flow so that we
Yes.
know what all files are.
Okay. So once you have this repository and the code space, open up the terminal. To open up the terminal, you can go here. Then I think it is terminal and new terminal, right? So you'll see something like this. Let me kill one of the terminals. Yeah, okay. So here just hit make, and you will see these lines printed here. Notice that it would go ahead and generate an
Hmm.
SD card.zip, and also it would have generated the kernel 8 elf and kernel 8.img. I'll kind of quickly show this again. So let me do make clean. All of these files should disappear. They are gone. Then let me do make. And if we see these two, and this file appeared here. And this is kind of, the zip file is what is
Hmm.
of interest to us. And we'll also go into details of how to, process that and deploy it on the Raspberry Pi. Okay, do we want to talk about the boot flow? How we
Yeah,
got to the...
maybe you show us the setup once again. Now
Okay,
with the components properly explained, and
okay,
see how
sure,
they look like.
sure. So let me unplug, right, and then let me speak to it.
Yeah.
So what we see here are these three wires, right? So this is the ground, and then just a moment, let me confirm which is which. Right.
I think.
So this is ground,
Hmm,
this is the TX, and this is the RX, and this is that cable
hmm.
of UART. And then let me kind of unplug this from my machine and then bring it over here. So this is kind of how the other end of the
Hmm.
cable looks like. Again, the Raspberry Pi, the SD card, and the cable, the link to that, if people want to get one copy for themselves, one piece for themselves, that's in the description. On the other side, the Raspberry Pi looks this way, right? It looks this way, and this is the SD card, and this is where we'll put all of the images, right?
Yeah.
All of the
The
important content.
package which we just
Right.
created.
And I should mention, so this is like the USB cable that's connected to my machine, and then we can have some SD card reader like this. These come in various shapes and forms. This is the one that I have, and if I plug it here, it'll kind of show up on my Linux. Okay, sorry, show up on my Linux machine, and we'll get into the details of this in a while,
Hmm.
right? But this is then kind of the setup that we require. And now, should we go to the boot flow? I think we
Yeah.
can talk about. So when we are talking about the boot flow, we're talking about the contents of the SD card
Hmm.
and how they affect or how they are,
Right. Right.
right? Okay, so let me go ahead and then kind of share the notepad.
Hmm.
All right, perfect. So we have this.
Yeah. Okay.
So let me recall the contents of the SD card. So we had something called the boot code. Okay, code dot bin. So this is one of the files that will get in the SD card
Hmm.
package. The other one is start. Oh, sorry, start 4.elf, and then the other one is kernel 8.img, and this was one of the files that the make command generated.
So, Piyush, can you also add one more file? I think it is the DTB file, device tree binary.
Yes, so
Uh,
something
the
dot
dot DTB. It's not
dtp.
really important for our experiment, but it's
Right,
something which we have to have it in the SD
comply
card.
with, kind of, yeah. And this kind of is part of their original boot
Yeah.
flow. And maybe at this point I can suggest this, that this kernel 8.img is usually the Linux kernel,
Hmm. Hmm.
right, in the normal boot flow
Yeah.
of the OS, the Linux OS on Raspberry Pi. And what we have done essentially is, instead of passing the Linux kernel, we are passing it one of our binaries.
Our bare metal binaries, which
Right,
we just saw the code for.
right. And then this, DTB, device tree blob, so to speak, is related to, the boot of the
Yeah.
Linux. And that's kind of, built into or
Right.
hard coded into the
Hmm.
start.elf, start4.elf. Okay, so how does the Raspberry Pi boot up?
Cool.
Let me
Uh,
also quickly
Before
talk.
that, Piyush, I would like to add, a justification as to why we chose Raspberry Pi
Sure,
and
go
not
ahead.
some any other board, right?
Yeah.
So the idea was, we are actually making a series about exploring the
Hmm.
A-class cores, with ARM v8 plus architecture, and Raspberry Pi 3 plus, 4 plus, and 5. All of them have now ARM v8 plus A-class cores, multiple such cores. So 3 has A53. I think 4 cores of A53 quad core,
Yeah.
right? 4B has A72, again quad core cluster. And the reason why we landed onto Raspberry Pi 4 was, first, it is very cheap. I mean, much cheaper compared to other
The
boards
fifth
available.
variant.
The other,
Yeah. And
yeah,
other variants. Yes.
yeah. And also with we could have also gone with 3B and all. It also has ARM V8 core, but the problem there was it had uh, a non-traditional, a very Raspberry Pi specific interrupt controller. And we thought that in later videos, when we are going to explore a generic interrupt controller GIC, that would hinder our,
Exploration.
exploration. Yeah. The the experiments which you want to show practically, that would not be possible if with Raspberry Pi 3. So hence why we landed onto Raspberry Pi 4, which has a generic GIC 400 as well. So I think with this board, we should be able to basically cover all of the items which we are planning to cover for the ARM A series exploration.
Right. Fair.
Okay.
So now maybe could you walk us through how the Raspberry Pi
Yeah,
boots?
sure, sure. So this is, a bit out of the like normal flow, where Raspberry Pi is a board which boots out of GPU core. It is a bit weird. Generally, all the other development boards you would see, one specific CPU core would be designated as a boot core, which would boot the Pi, which would boot the board. But here for Raspberry Pi, I think it's the VPU. It's called Video Processing Unit Core, which boots out of reset. So it has its own boot ROM, which executes obviously. And what it does is it kind of reads three interfaces. One is EEPROM,
Mm-hmm.
on device flash. Then if it SD card, and it has capability to also listen over USB for some recovery files. Okay, cool. So now in usual case, what happens is this boot ROM will load bootrom.bin, which bootcode.bin, which we just uh, see, yeah, which we just saw on the top there. That bootcode.bin is the next stage of the boot process, which will what it will do is it will enable the SD RAM, the clocks for other SoC, and then load start4.elf. So yeah, it will enable clocks, SD RAM, and then load start4.elf and execute that. Now you can consider start4.elf as like a substitute for U-boot. It's a bootloader which can boot high-level OS like Linux, kernel like Linux. And here, mind you, all the files which we just saw, boot code, start4.elf, are executing from a VPU. So our CPU core has not started its execution. So this is something which is not usual, but Raspberry Pi 4 follows this boot flow. Okay, and the start4.elf is the file which is going to take few files. One was the DTB, which is not needed in our case, but because the firmware requires it to be present, we have to have it in the SD card, and a file called kernel8.img. Usually, as Piyush mentioned, it is Linux kernel, but in our case, it is our bare metal code. And this is the actual code, or the very first code, which is executed by our CPU complex. So the A class core is actually executing the kernel 8.img straight away, without executing any other code prior. And yeah, just one more minor point to add, it is running in EL3, and whatever GPIO we exercised, UART we exercised is actually getting executed from EL3 firmware. Cool.
Right. So I think we are done with the boot flow.
Mhm.
How about now we go back and then show the SD card files, then show the make, and then from there let's try and set up the Raspberry Pi
Right.
and go from there, right? And maybe with that we can wind up the demo
Hmm.
for today. Okay, so let me then go ahead and focus on the screen that shows the Raspberry Pi again. just to briefly introduce, again, this is the Raspberry Pi. This is where the SoC is. And this is the Broadcom 2711
Yeah.
SoC. So if people want to kind of, look up the data sheet for that, in fact, that is what we use to write the programs. So yeah, that is the sheet to look for. Again, this is the UART. This is where the SD card goes, which we will now format and kind of from the scratch copy the files to. Okay, and then we kind of need a power supply. And if anybody trying this out follows all the steps but sees gibberish on the UART terminal, uh, change your power supply.
Only
We
God knows how much time we spent debugging it.
Yeah, 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 only to learn that. Okay, so
Yeah.
this is the SD card reader, and I have the
And that
SD
is a
card here.
very cool thing.
Very
It's
tiny little cute.
I mean, it's like it goes in the USB slot.
Yeah,
So
and then you kind of
hmm,
plug this in.
cool.
Okay, so also, by the way, this is the one that goes to your Linux machine. If you have Windows machine, you can also plug it into that. And
And you
then
can use
open the
something called Putty,
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 QtCom,
on
all of
on
those.
Windows. I mean,
Oh, okay, okay. PuTTY on Windows, yes.
yeah.
Okay, so what I'm going to now do is I'm going to plug this into this socket, which is also connected to my Linux machine.
Mm.
And let's shift the focus to the Linux machine. Right. Okay. Oh, there's a dog in the background. Great. Okay. So let me go ahead and okay, this was the terminal. Right. So let me put this aside. Let me also open this up. Right. So we have nothing in the downloads
Mm.
right now, and no, SD card. So let me plug it in. I've plugged it in, and we see this boot directory or boot media here, which is the SD card. And then, okay, let me just keep working here. And right, so let's go back here. So if we see all the files are here, forget the readme. The kernel 8 is here. Boot
Boot code.
code.bin, the DTB device tree blob, and the ELF. Right.
Mm.
Okay, what I'm going to do is shift back to the setup.
Maybe Piyush,
And
do you want to delete the
yeah, I
SD
will,
card
I
too?
will, I
Okay.
will. Yes, in fact, I will format that
Okay.
and show
Cool.
how to do that
Hmm.
also. But I wanted to show that this is now plugged in, and that's
Hmm.
how it's showing there. Right. So now let's come here and let's kind of type disk. So once you have the disks here, right, and mine is like this 999 MB driver. So what I'll do is just a moment. Sorry for the background noise. Okay. Right. So I will go ahead and stop this. Right. Then delete this partition, so it's completely wiped out. And then anyone who is trying, be sure to do this on your SD card. This is like my hard disk.
Yeah.
So don't wipe out your hard disk, do it on the SD card. And then create a partition, hit next here. You need not give any name. Be sure to select the fat
Hmm.
partition type here, then hit create. Okay, so the fat partition is created. Then click the plus play button here. That will kind of, okay, that has like mounted the drive here. And as you can see, there is nothing here, right, which is perfect. Let me now open a tab on the downloads directory because we want to do something there. So downloads directory, we go back to the code spaces, and now in this SD card we'll see all of the files except the image, kernel8.image, and that is what our code compiled to.
Yeah.
And what we do is create this zip file which has the kernel8.img and also the files available
Hmm.
here. So let me go ahead and right click here, click the download. Once I do that, you know should be downloaded. Then I will open up the downloads directory, and we see the sd card.zip. And this is where, there is advantage to using the code spaces. People can be on Windows, Mac, Linux, doesn't matter. All you need is this file, some way to format this D card, and copy files to that. So we will then extract. So the contents are extracted here. Go within that, select all of them. I like to cut things, so I cut them. Yeah, that was not a joke, but okay, I
Hmm.
like to cut things.
Hmm.
Right. Okay, so man. Okay, so I've cut and pasted all of the content here. Now I eject the SD
Yeah.
card. So that's out.
Make sure it that you click eject before actually ejecting it from the USB
Yes.
port.
Yeah, do not pull it out.
Yeah.
The card doesn't like it. Um, the contents might get corrupted and
Hmm.
all of that. Okay, so now what we have done is we have copied over and prepared the SD card. I also want to go back and briefly show the connections. So this
Hmm.
is how the Raspberry Pi was. This is how the header was. And on this pin number 8 and 10, which are also called GPIO 14 and
Right.
15, that's where the TXT and RXT
Hmm.
needs to go. And the ground needs to go on pin number 6.
So you leave the first two pins, top right
Right.
two pins, and then you connect the three
Yes, so you
from,
leave these
yeah.
two out and connect these three, right? Again, and the TXT, RXT, denomination or the identification that you can Google relating to the manufacturer or name of the cable that you have bought, right? So it's pretty easy to find that out. All right, so with this, then we are pretty much done. Let's go back to the setup and let me go ahead and get our SD card out, which is here. Then I turn this around, and load it
Yeah.
here, right? And then let me go back to the Linux machine, right? And I will go back to the terminal and briefly show how to the command that people can
Hmm.
use to. So yeah, sudo minicom -d /dev/tty usb 0 -b115200. That's the port rate. And once you have this, what I
Piyush,
yeah,
sorry. In some cases, depending on how many USB devices you have already connected to your system, the USB zero could be something else. It could be one,
sure,
two. Maybe you can try,
yeah.
with a different.
And let me kind of tell people quickly how
Hmm.
they can go about. So you can just type tty
Yes.
USB, and we see USB 0 here. Now what I'll do is remove the cable
Hmm. Maybe can you
and
do USB star? USB
yes,
star
I can do that. USB star. Yes,
star. Yeah.
that's a good one. So yeah,
There
nothing
is.
by the name USB, right? TTY USB. Now what I'll do is plug the cable back in the TTY to
Hmm.
UART or FTDI cable, and now we should see
Yeah.
TTY USB 0.
So
So that's how you
So
identify.
people can also do similar exercise. You would see one would be missing if you have not connected it, and if you connect
Right,
it and type the same command, you would see some device with some number USB, 123 whatever
right,
pop up, and that is
right.
what you have to connect it.
Right. And then the other way is to
D
look
message,
into
yeah.
the D
Hmm.
message. So I'm going to look into the D message,
Hmm.
and okay, it's asking me for password. And if we see, it kind of says that
Hmm.
there's a PL2330 converter detected. It's a prolific technology, something something, and exactly this is
Maybe can you
what
scroll
people
up?
can.
Scroll up because USB zero is not visible. We are kind of blocking. Our faces are blocking the
Oh,
message.
okay, okay.
Hmm.
Okay, okay, okay.
Hmm.
So maybe what I can do is I can do
Yeah,
this. Yeah,
exactly.
yeah, yeah. So these are the logs, right? And then it says TTY USB
Hmm.
0 here. That's how we know /dev/TTY USB
USB.
0.
Exactly.
And then this is essentially the converter that we are using.
Hmm.
And let's, briefly go over and quickly try and find that cable. CABEL maybe? Yeah. Right, this was the one.
Hmm.
And maybe we can quickly show which color is the TTY. Okay, so I think the white is the
I think they are
TXT.
following the uh, common color coding.
Okay, TXD is white,
Hmm.
RXD is green, and black is the
Black is
ground.
ground. Yeah.
Red here is the power, uh, the power supply pin, but we don't use it.
Hmm.
So that is that. Okay, perfect. So we have gotten all the logistics out of the way, I suppose. Let's go back here. And now, how do we launch the minicom? This is how. So sudo is for the permissions, super user permissions. Minicom is the utility. Minus D is the device. The path to device is /dev/tty_usb0. Minus B is for baud, and
Hmm.
115200 is the baud rate that we have selected. With that, I'll hit the enter or return key, and now it's waiting. Then I'll go back, and then let me kind of plug in. Once it's plugged in, uh, what we should see here. So it's taking a while because the VPU is booting up, and now
Yeah.
it has booted up our ARM core. Core 0 is the one that is printing this.
Yeah.
Other cores, they are doing some spinning or waiting for interrupt, whatever. But anywho, the core is printing this from the EL3. No other code is running on Raspberry Pi's A core. And now maybe, let's, okay, cannot open. Okay, lose connection. Never mind. That's that. So never mind the error. Let's go back here. Now, do we want to briefly talk about the code and the details of it, or should we just, you know?
I think maybe we can take it in the next video. It's
Yeah, sure, sure. Let's
hmm.
do that. Maybe the details we can kind of start to explain in another
Yeah.
video.
So currently, our we have deliberately kept the code, very tidy. We wanted to just show what 60 lines of code can do,
Yeah,
and without much commentation and all. We can
yeah,
probably add some comments, in the later commits as
yeah. So yeah, that was that, and this is the working environment that
well.
we will use, and kind of yeah,
Yeah.
maybe starting next video we'll deep dive into
Deep. Yeah. Our hope is to sort of pile on in this repository, add
right.
more stuff, add more experimentation, and touch base on a lot more nuanced features of ARM v8A.
Yeah.
All right.
And perfect. So for those of you who have stuck around, thank
Yeah.
you.
Thank you.
And you can head to the repository and try this out for yourself if you happen to have all the hardware.
Cool.
Yeah. We'll catch
Okay.
you up in next
Next video.
video.
Bye
Yeah.
bye.
Bye bye.